Hello students, welcome back to our YouTube channel Geeks for Geeks GATE Computer Science. So as you guys already know that GATE has launched its sample paper in GATE Data Science. So this is a new exam for everyone. So we have come up with the detailed solution of all the questions from that sample paper. And after the end, we are going to discuss that how many questions are from which subject and what kind of the difficulty level of the question. So that means we are going to do a small analysis of the exam after discussing all of the solutions. So we are going to discuss almost all the questions. Okay, and many of you have tried to do that paper, and some of the questions you are unable to solve, or some of the questions you are left with. So you can take help from this session, and if you haven't already solved it, so we are going to solve it together. So let's start the session. So first of all, I'll tell you that if you haven't seen the sample paper, from where you can download that sample paper. So you can see that I have gone through the website Gate 2024 IASC, right? So if you will write down Gate 2024 IASC on Google, you will get to this link and you will reach on this page, right? And in this, you can click on this download section, right? In this download section, you can see that in the fourth line, we have written here sample question paper for data science and artificial intelligence DA, right? If you will click on this, you will get a question paper here. So you can see that this is a whole question paper here, and it does not include general aptitude. The subject specific section will be preceded by general aptitude section in gate 2024, right? But that is not given in this sample paper. So you can see that we have questions for data science and artificial intelligence gate exam. So you can see that we have 55 questions. So we are going to discuss almost all of the question in this session. So let's start solving these questions one by one. Let's solve the gate sample paper for data science. So this is my question. This is my second question in my gate data science exam. It says that given three literals A, B and C, the number of models for the sentence A or negation B or C is. So we have to find out how many numbers of models are there for this sentence. So that means I have to see that in which number of models this sentence would be true, right? If it gives me true, I'll count it as my model. If it gives me false, then I'll not count it as my model. So what would I do? I'll find out the truth value. So how do I find out the truth value? I'll write down A, B, C, and then I can write down all the values: true, 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 and I can write down true, 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 and false, 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 right? And then I'll have here true, false, true, false, true, false, and then true, false. And then I can take here true, true, false, false, and then true, true, and then false, false. So if I'll find out the truth value for this A or B, sorry, it would be A or negation B, A or negation B or C. So you can see that because A is true, this whole value would be true. Similarly, this would be true, this would be true, this would be true, right? If I'll go through this, because C is true in these two conditions, it would be true. Now, but if I'll go through this last second condition, A is false, B is true, C is false. So negation of B will become false. So false or false or false gives me false, and all this would give me true because negation of B would become true and complete or would give me true. So you can see that how many number of times I am getting a true. 1, 2, 3, 4, 5, 6, 7. So out of 8 times, I am getting 7 times true. So that means number of models are 7. So for these three literals and for the sentence, we have 7 number of models, right? So this is a question. Let's go through the next question. So it says that which one of the following first order logic matches closest with the sentence, and the sentence is given to me: all students are not equal. That means I have to find out a logical language. That in logical language, how do I write down all students are not equal? So I can see that because we have given all, so that means we have to use for all notification notation. So that means there exists does not get used here. So option A is not true, option C is not true, right? All students are not equal. So that means, let's say for all x, for all y, x is a student and x is a y is a student, which imply that x is not equal to y, right? This seems true. But let's see option D as well. So it says that for all x, for all y, x is a student and y is a student, and x is not equal to y. But we do not require and here, because they are saying that if I'm taking students, then they are not equal. So that means I am getting if and then condition, right? If x is a student and y is a student, then they are not equal, right? So I can use implication here instead of writing and here, right? And means x is a student, y is a student, and x is not equal to y. But we want that if x is a student and y is a student, then x is not equal to y, right? So D is not true also. We have option B true. That means if x and y are students, then x is not equal to y. So that is what all students are not equal, right? That is a correct notation for all students are not equal. Okay, next question we have here is the mean of the first 50 observation of a process is 12, right? So we have given mean of first 50 observation, and that is 12. If 51st observation is 18, the mean of first 50 observation of the process round off to two decimal places. That means what is this question saying? That means they have given me a mean of 50 observations, that is given to me 12, and they have given me 51st observation, that is 18. Now they ask me to find out what would be the mean of 51 observation, right? So how do I do that? We have already solved so many questions on mean, and we know the definition of mean. Mean is what? If I have 50 observation, let's say x1 x2 x50 build up my observation, so I can write down here that x1 plus x2 plus up to x50 upon 50, right? That is what? That is my mean of 50 numbers, or and I can say that average of 50 numbers, and that is given to me too, right? So I can take this 50 to the right hand side. This would become 12 into 50, that would give me 600, right? And in the left hand side we left with x1 plus x2 plus x50, right? So I get here the sum of 50 numbers, right? I got sum of 50 numbers. Now 51st observation is 18, so can I find out here sum of 51 observation? Yeah, that is simple. What would I write down? X1 plus x2 plus x50, that means sum of 50 observation, and I'll add 51st observation, x of 51, right? That means in sum of 600 I am adding my 51 observation, that is 51st observation is 18. So I got here 618, right? This is my sum of 51 number. Now if I want to find out a mean for 51 observation, that would be mean for 51 observation. What would I do here? I'll write down x1 plus x2, and I'll say take sum up to 51. And instead of writing denominator as 50, I'll write down here 51. That means 618 over 51 gives me my mean, right? Of 51 observation. Now I can divide this value 618 over 51. So what would be the value? 51s are 51, and I'll left with 108, and that would give me 2. That means 102. And if I'll write down here, I'll left with 6. I'll use a point here, so I'll get a 0. Basic dividing. So I can write down here 51, and that would give me 9. Then I'll use point again here. So I'll get 90. I can write down 0.11. So I'll get something 12.11. And if I'll round off to two decimal places, I'll get my option B as my correct answer. Right? So this is a simple question based on me. You can solve it. Now, next question we have is the value of limit x approaches to 2, square root of x minus square root of 2 upon x minus 2. So if you remember, we already have discussed L'Hopital rule, right? Because first of all, you can see if you will try to put this x is equals to 2 in this limit, what would you get? Square root 2 minus square root 2. You would get square root 2 minus square root 2 upon 2 minus 2. That would give me 0 by 0 form. And we know that if I get 0 by 0 form, that is my indeterminate form. Indeterminate form. And how do we solve these indeterminate forms? How do we solve these indeterminate forms? We'll differentiate numerator and denominator with respect to x, and then we'll apply the limit. And this is what we call as our L'Hopital rule. So this limit would be equal to limit x approaches to 2 I can differentiate numerator. Differentiation of square root of x is 1 upon 2 square root of x. And if I'll differentiate denominator, that would give me 1. So if I'll differentiate, I'll get the limit 1 by 2 root 2. So here option C is correct. Right, so for question 5 we have option C is my limit. And also you can either, if you do not want to use it, you can solve it using cross multiplication. Sorry, if you do not want to use L'Hopital rule, you can rationalize this function as well. What would I do? Because I have limit x approaches to 2 square root x minus square root 2 upon x minus 2. So if you will multiply numerator and denominator with square root of x plus root 2 and square root of x plus root 2, if you would multiply numerator and denominator with this value, what would you get? Limit x approaches to 2, I'll get from the numerator x minus 2 and x minus 2. A minus b and a plus b would be a square minus b square. That's from here why I got 1 x minus 2, and I can write down here square root of x plus square root of 2. Now these x minus 2 and x minus 2 get cancelled. I can put this value 2 in this limit. I'll get 1 by 2 root 2, because root 2 plus root 2, 2 root 2. That's how I get the option C as my correct answer. So you can see that you can use any of the method to solve these questions, but L'Hopital rule usually help us to find out limit in any of the question. But the condition we have to use is that either it is a 0 by 0 form, in infinity by infinity form, these kind of form, the forms which we call as indeterminate form. Okay, so this is a question based on limit. Now next question we have is, which among the following typically reduces overfitting in a supervised machine learning algorithm? So this is a machine learning algorithm question. So what is an overfitting? Overfitting, we know that if I, let's say if I have some data points, and we have fitted our data very perfectly, that means we get a curve like that, we have done we have got a something we have fitted the graph. That means we have fitted our graph for training points perfectly, right? So what would happen if I'll fit my graph to the training points very perfectly? It would not work on my test data set, right? So if I'll give new example to this algorithm or this model, it would not work for that. It would give me a incorrect answer. So I want a model that would fit, but not fit very much, right? It does not overfit the data. So for that, what would I do? Because, and you know that overfitting occurs because we have taken model complexity too high, right? So if I'll reduce the model complexity, then overfitting can be managed, right? So let's say if I have taken x square, x cube, we have taken so many terms, right? So I can decrease those terms, or I can add regularization parameter is to decrease the model complexity. So that's why option first cannot be correct. So second would be to reduce model complexity. And it's saying that increase the number of training points. Yeah, that would be true. If I'll increase the number of training points, that would help me to get a better idea about the data set, right? So third would be correct. But if I'll reduce the number of training points, that would not help me to reduce overfitting, right? So fourth would not be true. So which option is true here? Second and third gives me correct answer, right? So I can reduce overfitting by reducing model complexity, or if I'll increase the number of training points. Okay, so that's how I'm going to reduce overfitting. Similarly, you can work on underfitting as well. Underfitting means that we have to increase model complexity to work on underfitting, right? So yeah, this is the question on machine learning. Let's see next question. So again, this is a question from mathematics, that is probability. A fair coin is flipped twice, and it is given that at least one tail has been observed. The probability of getting two tails. So either you can solve it using conditional probability, or you can solve it directly as well. So first of all, they are saying that we have flipped a coin twice, and at least one time we are getting a tail. So what would be our sample space? Because in simple case, when we toss a coin twice, we get a sample space that is head, 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 tail, tail, head, tail, tail. We get 4 points in that sample space, 4 elements. Right now, the it is given to us that at least one tail has been observed. Right? If one tail has been observed, that means head case, I'll not take it. Right? So our sample space would become tail tail, tail head, and head tail. This would be my sample space. Now they are asking that probability of getting two tails is. So what would be the probability of getting two tail in this sample space? Because we have only one element here that has given me two tails. So 1 by 3 is my probability. So option B is correct. And this similar question is also gets asked in GATE computer science, in which instead of asking about tail, they have asked about head. And you can also solve it using conditional probability. What you would do, you would take that sample space A has that a fair coin is flipped twice, so the whole sample space. Like what I mean here is that if I'll take A experiment is that A fair coin is flipped twice. So our sample space for this fair coin is flipped twice. Or what I can say here, instead of taking A as A, my experiment is that fair coin is flipped twice. I have to take an event. Event is that at least one tail has been observed. At least one tail has been observed. One tail has observed. Right? And I'll take B event as that getting two tails. Getting two tails. So I know that A has already occurred and I have to find out probability of B. So that means probability B given A I have to find out. So I can write down here probability B intersection A upon probability of A. And what is B intersection A? B intersection A, in this A experiment, I want that one tail has been observed, and in this B experiment is getting two tails. So that means getting two tail would be B intersection A, right? And my main sample space would be here head tail head, and tail because my I have flipped coin twice. So I got a probability here 1 by 4 and probability of A. That means at least one tail has been observed. So I can see that I have three cases in which one tail has been observed. So 3 by 4 is the probability of A. So if I'll solve it, I'll get 1 by 3 as my probability. So it's up to you if you want to solve direct this question or if you want to use conditional probability. Okay, so yeah, that is a question from probability. Let's move to the next question. So this is another question. It says that given n particles and m boxes, we place each particle in one of the boxes uniformly at random. What is the probability that no box receives more than one particle? Right? We have to find out that what is the probability that no box receive more than one particle. So we have to find out that probability. So this is a question from combinatorics. So we have n particles and m boxes, right? We have m boxes. These are m boxes. And we have n particles. And we have to place these n particles in these m boxes such that one box receives no more than one particle. So at most we can put particles one, right? And these number of boxes obviously is greater than number of particles. So that means some boxes remain empty, some boxes have particles. So we have to find out what would be the what would be the probability here. So in denominator, because we have to consider all the cases, so that would be because for first particle we have m choices, for second particle we have m choices, for third particle we have m choices, so we'll get m into m into m. So that means that would become m to the power n. So for every particle we have m to the power n choices. So now for the next one, we can see that because we have to take n particles in m boxes, right? So for first box, for the first box we have n particles choice. Sorry, for n particles, let's say if I'll pick one particle out of it. So for that first particle, I have m box choices. So I can put in any of the box, right? I can put that first particle in any of the box. Now for the second particle, because we have taken this one particle and this mth box, let's say if I have taken one box for it, then I am left with m minus one particle. and now I have to move m minus 1 boxes, and now I have to move for second particle. Now for the second particle, how many choices I have? I have m minus 1 choice. Because I have placed that second particle in a box, so I can't use that box again. So I am left with m minus 2 boxes, right? So I can place m minus 2 box. I can place third particle in m minus 2 box. And similarly, we have n particles. So I can place m minus n plus 1. That means nth particle in m minus n plus 1 box, right? So that's why we get our this would be our probability. But if you will see that no option is going to match our answer, so let's start solving this. So you can see that m factorial upon m minus n factorial would give me m minus 1, m minus 2, m minus n plus 1. That means basically if I'll cancel out m minus n factorial from the denominator and m minus factorial from the numerator, I'll left this term. So I can write down this term as m factorial upon m minus n factorial up into m to the power n. So option B is correct here, right? So I have to consider this question like I have n particles and I'll start placing one particle in one box, and if I have taken one box, I can't take that box again. So I am left with m minus 1 boxes. So for the remaining particles, I have m minus 1 box choices, right? So if I'll pick another particle, I can place it in m minus 1 box, right? So m minus 1 choices for second box we have. For the third box, we have m minus 3, 2 choices, and we will go on this way to solve this question. So this is the next question. In this question, it says that for two events A and B, B is a subset of A. And then we have to tell them which one of the following is correct. So I can see that in options, they are asking about A given B and B given A. So let's see first. If I'm saying that A is a subset, sorry, B is a subset of A. That means this is B and this is A. So if I'll go for probability B given A, that means it would be probability B intersection A upon probability of A. And what is B intersection A? It would be probability of B, right? B intersection A would be B because B is a subset of A. I can write down probability of A. Now I have to find out that probability B given A is greater than equal to probability of B, or it is less than equal to probability of B. So, and I know one thing, that probability of B is always less than equal to probability of A because B is a subset of A. Now we can see, let's take probability of B as 1 by 3 and probability of A as 1 by 2. And I can see that probability of B is less than equal to probability of A. So if I'll fill this value, what would be probability of B? 1 by 3 and 1 by 2. So I can see that I'll get the probability 2 by 3. So probability B given A is greater than probability of B because probability of B was 1 by 3. So so that means option A is correct. Option B would be incorrect because you can see that probability of B I can find out using my whole sample space would be, the number of values in my whole sample space would be in the denominator, and the values occurring under the event B would be in my numerator. And in B given A, denominator would be less because in denominator we have the values which occurs under A, and A is my event. So that means there would be less value as my whole sample space. So that's why B option is incorrect. Now let's talk about A given B. So if I'll take A given B, that means again probability A intersection B upon probability of B. And what is A intersection B? That is B. So I'll get probability of B upon probability of B. These two values get cancelled, I'll get. So C is incorrect and also D is incorrect. So that's why option A is correct. Let's see next question. This is another question based from probability, right? So it says that X is a random variable with support minus 2 to 2 union 99.5 to 100.5. So that means X is given to me on an interval, right? From minus 2 to 2 union 99.5 to 100.5. The PDF of X, that means probability density function, right? That means it is continuous, and it is also given on an interval, so it is also continuous, is such that it is equal to a constant c inside its support and 0 outside. We have to find out expected value. So if you will see, we have given a probability density function, and they are saying that it is c in this interval, in this support, -2 to 2 union 99.5 to 100.5, right? And we have given 0 value otherwise. At any other place we have 0 value. Now they ask me to find out expected value. So for expected value, first we have to find out the value of c. And you guys know that integration, or if I'll talk about discrete, then summation, over the whole real number line or over the whole interval, we'll get the integration 1, right? Because we know that sum of all the values of a probability gives me 1. So here, because it is given to me 0 on any other value and c on these intervals, so I can see that if I'll integrate from -t2 to 2c and 99.5 to 100.5c, I'll get value 1, right? Dx, right? So I can solve it to find out the value of c. Let's take c common, and if I'll solve this integration, I'll get x, and if I'll solve this value, I'll get the integration x, and this would be -2 to 2, and this would be the integration x, and this would be the value 100.5 to 99.5, and that would be 1. So if I'll solve it, this value would become 4 and this value will become 1. I'll get the value of c, that would be 1 upon 5. So I get the c value. Now I have to find out the expected value, and we know that expected value, for the expected value I have to integrate from -infinity to infinity x f x. Again, because it is given to me, it is non-zero on these intervals, so I'll integrate on these intervals. So that means if I'll integrate from -2 to 2 and cx dx plus 99.5 to 100.5 c dx cx dx, and if I'll integrate this and put the value of c, I'll get a value 20. You can solve it by yourself. This is basic integration. You can solve it to get a value 20. Okay, what you will do, you will take c common, and if you will integrate, this would become x square by 2 and -2 to 2 plus x square by 2, again integration of x, and that would be 99.5 to 100.5. Now you can solve it, bracket part, and put the value of c, that is 1 by 5. You will get the value 20 on calculation. Okay, so this is a question based on probability. Now let's see next question. Okay, so this is again a question from machine learning. It says that a binary classification data set contains only 5% of positive instances. Which one of the following experimental design and performance measures is most suited for measuring the generalizability of a classifier trained on this data set? So you can see that if I have given 5% of the data set that is positive, that means 95% of my data set negative, 5% of my data set positive, then I have 95% of my data set negative. So let's say if I'll train a model, and if I'll give all the 100% value negative value, then 95% of times my model is giving me right answer. But that is not a correct model, because it is not giving me positive at any point of time, right? So accuracy didn't work, because I'm achieving 95% of the accuracy, and if I'll give negative to all the instances, negative value to all the instances, and we are achieving 95% of the accuracy, but that does not work out. So accuracy thing does not work on this data set. So that means A would not be true, C would not be true. Now, in option B, they are saying that fixed training and test data set. Why I have cancelled option A and C? Because they have accuracy, right? I can't work on accuracy right here, because we are achieving accuracy 95% of times when we are giving negative to all the instances. But we are saying that, but that is not a correct model, because we are not getting any positive value. Okay, now if I fix training and data set, test set, if I fixed the data set, then I would not be able to get my positive and negative instances. So that's why we have to shuffle again and again. That means we have to use resampling. We have to use sampling method, and that would be done by stratified cross validation. So stratified cross validation would help me to work on sampling. And area under the ROC curve. So in this, we'll find out precision, recall, and all these value gives me true positive, true negative rate. All these things help me to work on these kind of unbalanced data set, because this is unbalanced data set. So that's why option B is also incorrect, because we cannot work on fixed training and test set. We have to resample our data set. So that's why option D is correct. Right. So unbalanced data set, we have to first resample, we have to use sampling, and then we have to use area under the ROC curve. Okay, so this is a question based on machine learning. Next question we have is from DBMS. It says that consider two relations RXY and SXZ. R has 100 records, S has 200 records. What would be the number of attributes and record of the following query? Select star from R, cross join S. So that means we have to select star from R cross join S. So you can see that we in R we have XY and XZ. So that means we have four attributes here: X, Y, X, Z. So attributes are four. Attributes are four. And because cross join, how does cross join work? It would take a Cartesian product, right? And in Cartesian product, because R has 100 record and S has 200 record, so in total we have 100 into 200 records, because it would make tuples from R and S, and then we'll get a Cartesian product. So that means we have how many records? 100 into 200, that would give me 2000 records. Sorry, 20,000 records. So that means option B is true. We get four attributes and 20,000 records. This is a simple question. Next question we have is from DBMS again. It says that consider two relations RXY and SY. Perform the following operation: RXY divide SY. If X is a relation returned by the above operation, which of the following option are always true? So RXY divide SY. So let's say we have a table which contains X and Y, and we have a table which have only the values of Y. And because if X is a relation returned by the above operation, so at the end we are getting X relation, right? So which of the following is always true? So they are saying that cardinality of R, X is less than equal to cardinality of R. So you can see that, let's say my 3 value gets mapped to 2 and 3 value get maps to 4, right? So in Y we have 2 and 4. So if I'll take RXY divide SY, so we'll get cardinality of X here. Cardinality of X here is 1, right? And 1 is less than equal to cardinality of this relation R, that is 2. So that means option A is correct, B is also correct, and C is also correct, right? So A, B, C, 3 options are correct here. D is incorrect because I can see from this example. So that's why here A, B, C are correct. Okay, so now let's see next question. Again, this is from DBMS. It's saying that which of the following statement is /R? They are saying that every relation in BCNF is also in 3NF. So we know that if I am talking about binary relation, that it is also in 3NF, right? A is true. So you all have studied these. Every relation with two attributes. Two attributes means binary operation. So that is in BCNF. That is true, B option. No relation can be both in BCNF and 3NF. That is incorrect, because of the previous example. We have said that every relation with, sorry, because of the A statement, every relation in BCNF is also in 3NF. So that means there is something in common. There are some relations which are in BCNF that is also in 3NF, right? So that means option D cannot be true. Similarly, for option D, every relation in 3NF is also in BCNF. BCNF relation is in 3NF, that is true, but converse is not. So D is also incorrect. So A and B are the correct option for this question. Yeah, let's see next question. This is question from linear algebra. They're saying that we have given a matrix H, then we have to find, they have given one of the eigenvalue. We have to find out other eigenvalue. So how would we do that? So if you remember, we have one statement which says that sum of the eigenvalues is equals to trace of a matrix. So let's say if I'll take a sum of eigenvalues, because it is a 2 cross 2 2 cross 2 matrix. So we have two eigenvalues, let's say lambda 1 and lambda 2. Their sum would be equals to trace of a matrix. Trace is given to me 9 plus 6. Trace is what? Sum of elements on diagonal elements. So it would give me 15 as a sum, and one of the eigenvalue is given me 5. So another eigenvalue would become 10. So option B is correct. Simple question and easy one. Next question we have is two non-zero vectors x and y are perpendicular if. So we know that they are perpendicular if x transpose y is 0. Either we can say that perpendicular or orthogonal, anything. So option A is correct. This is basic definition of perpendicular vectors. Next question we have is, we have given a function and they asked me to find out maxima, minima or saddle point. What does this function have? So what would I do? We know that to find out maxima or minima, we'll first find out the first derivative, equate it with 0. Then we'll check the sign for second derivative to check that it has maxima or minima. So what would I do? I'll find out the f dash x. So differentiation of 1 is 0. Differentiation of x is 1. Differentiation of x square is 2x. Now next step would be I'll equate it with 0. So on solving, I'll get the value of x is minus 1 by 2. That means I can say that minus 0.5. Now I have to find out double derivative of x. That would give me 2. And this derivative, double derivative, is greater than 0. And if it is greater than 0, then means we have a minima here. We have a minima. If double derivative is greater than 0, then we have a minima. So we can say that we have a minima at x is equals to minus 0.5. So option C is correct. So we have a minima in this case. Simple question. Just take first derivative, equate it with 0, find out the sign of second derivative at that point, then we'll get a maxima or minima. If it is second derivative is greater than 0, then we have minima. If it is less than 0, then we have maxima. Okay. Now, next question. They ask me to find out Pearson correlation coefficient between x and y for the data in the table below. What is a formula for Pearson relation coefficient, correlation coefficient? So correlation of x comma y, we can find out as covariance of x comma y, square root of variance of x into variance of y. So this is a formula. Covariance of x comma y would be, its formula is expectation of xy minus expectation of x into expectation of y upon square root of variance of x into variance of y. So this is basic calculation. So you have to solve it. You know how to find out expectation of xy. That would be summation xy minus summation of x and summation of y. And square root of variance of x. Variance of x would be, the formula is summation xi square. You have to take over n here as well. Summation x, summation y. You have to solve it like this, and you can solve it by yourself. Just solve all the calculation, and we have discrete points here, and you can see that we have given here 5 points, right? So for these 5 points, you can solve it to find out the answer, right? So if you will solve it, you will get option A as your correct answer if you would solve. So this is the next question. It says that first, the worst case running times of insertion sort, merge sort, and quick sort respectively are. So you have to remember worst case time complexity for all the sorting algorithm. So we have number of sorting algorithm. You have to remember that. And for this question, for insertion sort, we have O of n square. For merge sort, we have O of n log n. And for quick sort, we have O of n square. So C is correct. So these are worst case running times, or I can say that worst time complexity. Okay, so this is the next question. It says that consider the following program. So we have given a definition of a function and it takes an integer n. If n is less than equal to n, 1, then it return n, else return 3 into function n minus 3 minus 3 into function n minus 2. So that means this is a iterative function, right? So this is a recursive function. We have to use n minus 3, and we have to apply function definition, and we have to use n minus 2. We have to use function definition. So it is similar to Fibonacci sequence, right? So Fibonacci, what is Fibonacci? Fibonacci is same that f of n is equals to f of n minus 1 plus f of n minus 2, right? So we'll use previous two previous two values to find out the next value, right? So it is also recursive. So this is given to me same, and they ask me to find out a running time of the above function. So we know that running time of this for this Fibonacci sequence is O of 2 to the power n. So we have the same running time in this as well, because it is similar. We only have multiplied it with 3 and take a subtraction instead of summation, so it would be same. And if I'll see that, it would become T of n is equals to T of n minus 3, or I can say that T of n minus 1 equals to T of n minus 3 plus T of n minus 2 plus O of 1, right? So I can calculate time complexity for this, the running time for this function as well using this. Instead, we can compare it that it is similar to Fibonacci, and for the Fibonacci, we know that the running time is O of 2 to the power n, so it would be same for this function as well, this function as well. Okay. Now, the next question we have again, it is from algorithm. It says that which one of the following equation correctly describe the recurrence relation for standard binary search algorithm on a sorted array of n number where c is a constant. So what we do in a binary algorithm, we'll take the input, divide it by half, and then we'll add a constant. Right? This is our binary search algorithm. So you can see that it is given to me in option D. Right, what we are taking an input, taking it half of it and adding one constant. So option D would be the equation which describe the correct binary, which describes the recurrence relation for this binary search algorithm. Next question we have is, again we have given a Python program, and you can see that in this Python program we have given a function definition, and it takes the value capital A, N and M. S is equals to A of 0 for I in range from 1 to n minus 1. M is equals to M star S plus A of I, and then we'll return M. And Z be an array of 10 elements with Z of I is equals to 2 for all I varying from 0 to 9, and the value returned by the function Z10 comma 2. So we have to find out that value. So that means in this function we have to find out the value Z comma 10 comma 2. Right, so in this I can say that A is equals to Z, and I can say that N is equals to 10 and M is equals to 2, and they are saying that Z is an array of 10 element, and Z of I is given to me 2. So I can say that Z would be what, 2 comma 2 comma 2 comma, and we have this array up to all the elements in this array is 2, right? So I can say that this is my array, right? So it has all the values too. Now is A of 0, that means S is Z of 0, so I can say that S would be 2. Now there is a loop which moves from 1 to n minus 1, and it is moving from 1 to n minus, the range is given to me from 1 to n minus 1. So I know that in Python it will take value, I would take value from 1 to n minus 2, and we have to apply this loop that M is equals to M star S plus A of I. That means M would become M star S. What is M? M is given to me 2, and then we'll have star S. S is 2 and plus A of I. That means if I'll take I is equals to 1, right? Let's apply the loop. Let's go through the loop. So if I is equals to 1, if I is equals to 1, then M star S would be 2 into 2 and A of I. That means A of 1. A of 1, I can see that this is A of 0 and this is A of 1, right? So we'll get 2. So 2 into 2 plus 2. That will give me 2 into 2, 4 plus 2, that is 6. Then I'll move for I is equals to 2. For I is equals to 2, now M is 6 here. So it will become 6 into 2 plus A of 2. A of 2 is again 2. This value is 2. So 6 into 2 plus 2, that would give me 6 into 2, 12 plus 2, that means 14. And I'll move further. I'll take I is equals to 3. Then M is equals to 6. Sorry. Now M would become 14. 14 into 2 plus 2. 14 into 2, 28 plus 2, that is 30. I can move this way, and I have to move up to n minus 2. And n is given to me 10. That means I have to move up to I is equals to 8. And the final value I'll get at I is equals to 8 would be my final value. So either one option is that I'll find out value for I equals to 4, I equals to 5, I equals to 6. I would do that. Or I can see that if there is some logic it is following, or some sequence it is becoming. So I can see that if I'll write down 2 to the power 3 minus 2, that would give me 6. 2 to the power 5 minus 2, that would give me 14. And if I'll write down 2 to the power, sorry, this would be 2 to the power 4 instead of 2 to the power 5. 2 to the power 5, that would be 2 into 2, 4, 2, 8, and then 1 2 gives me 16. So 16 minus 2, that is 14. That would be 2 to the power 5 minus 2. So what is it's becoming for I? If I am finding out at I, then m would becoming 2 to the power I plus 2 minus 2. So for I is equals to 8, m would become 2 to the power 8 plus 2 minus 2. That means 2 to the power 10 minus 2. You can solve for 2 to the power 10. 2 twos are 4, 2's 8, 16, 32, 64. And then we have 128, then 256, then 512, and then we'll have the value 1024. 1024 minus 2 gives me the value 1022. Right? So the value returned by Z 10 2 would be 1022 would be the value. Right? So that's how you can run this function and get the value. We have find a logic behind that, or we have form a sequence, because here they have given me n is equals to 10. They can take any more value for n, and then it would be difficult for us to find out by finding out the value I equals to 1 2 3 4 5 each of the value. So that's why we get the logic that m would be 2 to the power I plus 2 for I, for ith value, right, for ith loop. Okay, so 1022 is the answer. Now, next question we have is two eigenvalues of a 3 cross 3 real matrix X are I, 1 plus I and 2. Then we have to find out the determinant of the matrix. So as you can see that eigenvalues are given to me 2 only, and they are asking me to find out a determinant because it is a 3 cross 3 matrix. So there should be 3 eigenvalues, right? So I can see that eigenvalues are a roots of characteristic equation, and characteristic equation is what? Polynomial. And we know that complex roots always occur in pair. If 1 plus I is a root, then 1 minus I would always be a root. So that means 1 plus I is an eigenvalue, then 1 minus I would also be an eigenvalue, and it too 2. And determinant of a matrix is product of eigenvalue. So I'll take a product here. I'll get 1 square minus I square. That would become 2 into 2, right? I square is minus 1, minus minus plus 1 plus 1 2. So 2 into 2 gives me 4, right? So I get a determinant of a matrix as 4. A simple linear algebra question. Now next question we have is, which of the following relation instances, given the following relation instances, which of the following condition is are true? So we have to tell them that which of the uh, condition is true. This is a relation schema. So I have to check that when I'm taking xy, then I am getting z here, and when I'm taking z, then I'm getting y. But if you will see that this xy, 1 4 is giving me 2, 1 5 is giving me 3, 1 4 is giving me 2. 1 4 is giving me 2 here, and 1 4 is giving me 3. So that would not be true, right? Because single left hand single value cannot map to two distinct values. So this would not be true. Now for z imply y, right? If I'll put z, then I'm getting a y. So when z is 2, I'm getting 1. When z is 3, I'm getting 1. Z is 3, I'm getting 1. Z is 2, I'm getting 1. And 1 is 3. But this is true. Z imply y is true. But because this is not true, so option A is not correct. Simply if I'll go for yz implication x, right? If I'll go for this relation yz imply x. So 4 2 giving me 1, 5 3 giving me 1, 4 3 giving me 1, 5 2 giving me 1, 2 1 giving me 1. All the inputs are distinct. So this is true. But when I'll take for x imply y, that means 1 imply 4, 1 imply 5. So single value mapping to two values, 4 and 5. So B is also incorrect. Simply you can check that C and D is also not matching. So I think there is some error in the question. So I'll go through it later, and we'll let you know that if there is an error in the question or anything like that. So this is the next question. It says that given a K-class dataset containing n points where sample points are described using d discrete features, with each feature capable of taking v values, how many parameters need to be estimated for naive Bayes classifier? So if you have studied naive Bayes classifier, so you can remember that we have to find out all the probabilities, right? Probabilities in each of the uh, in each of the discrete features, right? So let's say they are saying that in a given a k class data set we have containing n points, and we have the discrete features and each feature capable of taking v values. So that means we have d features here, d discrete features, and each feature can take v values, right? Each feature can take v values, and we have a k class data set. So that means if I'll take all these combination possible, then I can get k classes possible. And also in this we have given n input points, right? N input data I have of n points. Okay, so if I'll first find out all the probabilities, so I have to find out all the probabilities for these features, right? For these distinct features, and each distinct feature has is capable of taking v value, so d into v, and because of each corresponding class we can find out the probability, so kdv. And then I have to find out each of the class probability in naive bayes classifier. If you have studied naive bayes classifier, then we have to find out the probabilities, probability of c1 c2 ck, like that. And that would, so that's why we have to add this k. So that's why option C is correct, right? So I have to calculate all these probabilities. So that's why VDK plus K parameters I have to estimate for naive bayes classifier, right? Let's see next question. It says that for a perfectly spherical 2D data centered at origin, which all of the following pair of vectors are possible pair of principal components? So if you remember, principal components needs to be orthogonal and they have to represent my 2D circle, right? So I can see that first is orthogonal 1 0 and 0 1. If I'll multiply these two, I'll get 0, right? And second is also orthogonal 0 1, 0 minus 1 and minus 1 0. Second is also orthogonal, but the third one is not orthogonal. The third is not true. First and second represent my spherical data centered at origin, that is 2D spherical data. So first and second option is true. So that's why option D is correct here. First and second statement are correct. That's why option D is true. Okay, next question we have is x is a uniformly distributed random variable from 0 to 1, and then we have to find out variance of x. We have given the function fx that would give me my probability density function. They ask me to find out variance of x. So if you remember, what is the formula for variance of x? Expectation of x square minus expectation of x ka whole square, right? And to find out expectation of x square, I'll integrate x square dx from minus infinity to infinity. But the function is given to me only 0 to 1. So x square into 1 from 0 to 1. Similarly, expectation of x would be 0 to 1 x dx, and then I have to take a square of it. So x integration of x square will give me x cube by 3, 0 to 1 minus integration x square by 2, 0 to 1, and then I have to take a square. So this would give me the value 1 by 3, this would give me the value 1 by 2, and I have to take a square of 1 by 2. That would give me 1 by 3 minus 1 by 4. Now I can solve it. 12, 4 minus 3. That would give me the variance of x as 1 by 12. So that's why option D is correct. A simple variance formula, expectation of x square minus of expectation of x ka whole square. That would solve my problem. Next question we have is 1 plus 2x plus 3x square, and it goes up to 2026x to the power 2025. So we have given one function. They are asking which of the following statement is true. So they are asking for global minima, global maxima, and continuity. First of all, it is given to me as a polynomial, right? Power goes up to 2025, but it is a polynomial. So it would always be continuous. We have discussed that exponential, polynomial, all these functions are continuous. So that's why option D cannot be true. Now let's talk about global minima or global maxima. So if I'll talk about global maxima or minima, so if you remember, let's say if I'll take a line, so it would be something like that. Then it would goes up to infinity, it would goes up to negative infinity, right? But if I'll take a square polynomial, because first of all I have taken this 1 plus 2x, it would some line. If I'll take 1 plus 2x plus 3x square, then because of quadratic power we'll get one parabola. If I'll take power up to cube, 1 plus 2x plus 3x square plus 4x cube, right? So we'll get some this kind of a curve. This is a cubic curve. If I'll take a power 4, right? If I'll take a power 4, then I'll again get some kind of a parabola. And if I'll take a power 5, then I'll again get a some uh, this kind of a function. It goes up to positive infinity and it goes up to minus infinity as well. Similarly, when I'll go for power 6 value, we'll get some kind of a parabola kind of a graph. So that means when we have a even power, then we'll get a minima. But when we have an odd power, we do not get a minima, right? We neither get a minima nor get a maxima, because x cube does not have a minima and does not have a maxima. So a odd power function behaves in a same way. You can plot the graph and check by yourself. So in this case, fx does not have a global minima. A and B would be incorrect, right? Fx does not have a global minima. So fx have a global minima if I'll have here even power, right? If I'll have here even power, then I have a global minima. Otherwise, we do not have a global minima, and global maxima does not occur in polynomial case. There would always not be a maximum, because when x values increases, the polynomial value gets always increased. There might be a possibility if I'll take a negative sign, right? If I'll take minus of x square, so then this kind of a parabola we'll get, right? This kind of a parabola. So then we'll have a maxima. Then in that case, we do not have a minima, because we do not have a negative value here. So that's why I'm not considering about maximum, right? So fx does not have a global maximum. Now, the next question we have is, consider the following statement. A smooth twice differentiable function can have a global minima. Differentiable function can have all smooth differentiable function have a global minimum. Again, this is a question from calculus. A smooth function is, that means there is no holes, no lumps. That means we can say that it would be continuous, and also it considers also sharp points as well. So a smooth twice differentiable function can have a global minimum, right? That can be true. If I'll take x square, this is smooth differentiable twice differentiable function, and we know that it has a minima at x is equals to 0, global minimum. This I'll consider as my global minimum. So they are saying that a smooth twice differentiable function can have a global minimum. They can get a global minimum. That is true. P is true. But when now they are saying that all smooth twice differentiable functions have a global minimum. That means all the functions that are twice differentiable have a global minimum. That is not true, right? Because if I'll take a function x cube, this is a graph of x cube, right? This is a function graph of x cube, and it does not have a global minimum, right? So that's why P is true. They can have a global minimum, but it is not compulsory that all the functions should have a global minima which are smooth and twice differentiable. So P is true and Q is false. So B is my correct option, right? So here B is my correct option. Now, next question we have is from probability. It says that consider the following joint distribution of random variable x and y, and we have given this fxy function. They are asking me to find out conditional probability density function of x given y. That means they are asking me to find out f of x given y. That means I can write down this as f of xy upon f of y, right? So f of xy I already have. That means I have to find out f of y. How do I find out f of y? That means I have to find out marginal distribution of y. How do I find out marginal distribution of y? If I'll eliminate the value of x, and how do I eliminate the value of x? By integrating. So I can say that x into 1 plus 3y square by 4, and I'll integrate with respect to x. I only left with y value here. So x limit goes from 0 to 2. Now I can integrate 1 plus 3y square by 4, considered as a constant, so I'm taking it outside because I have to only integrate x. So integration of x would be x square by 2. So if I'll take a value 0 to 2, I'll get 1 plus 3y square by 4 into 4 by 2. So 2 2s are 4, 2 2. So we'll get f of y as 1 plus 3y square by 2. Now I can replace these values. So what would I get? 1 plus 3y square by 2. So if I put f of xy, so it will become x into 1 plus 3y square by 4 upon f of y. F of y is 1 plus 3y square by 2. And if I'll cancel out this value, 2 into 2, that would give me x by 2. Right? So option C is correct here. Right? X by 2 would be my conditional probability density function of x given y. And all the values of y get cancelled here because in integration y remains same. Right? X by 2 would be the probability density function of x given y. Yeah. This is the next question. They are asking for me, we have given a matrix H and they are asking that to find out the eigenvectors. We have given one eigenvector, we have to find out other eigenvector. So one method is that I can go through the whole definition. First I'll find out the eigenvalues, then I'll find out corresponding eigenvectors corresponding to eigenvalues. But that would be very lengthy and they have already given me eigenvector. So if you remember, eigenvectors are orthogonal to each other. So if I have to find out another eigenvector, if I'll multiply two eigenvectors of a matrix, then their multiplication should be 0. So if I'll go through this 1 into minus 1. So if I'll multiply minus 1 into minus 1 with 1 minus 1, that means I'll get here minus 1 plus 1. That would give me 0. Yeah, so this option A can be possible. Let's see one by one that another one are possible or not. If I get two eigenvectors possible, then that would be wrong, right? So I go through that, then I have to check by the longer method, but I am applying here orthogonal property. So if I'll multiply 1 with 1, I'll get minus 1 into minus 1, that would give me minus 2. So this is not true because they are not orthogonal. Again, minus 1 gets multiplied with 1 and 0, that would give me minus 1, not 0. So option C is also not true. Minus 1 minus 1 and it gets multiplied with 0 and 1. So I can see that I'll get minus 1. So D is also not true. So I can simply take option A because of the orthogonal property, their multiplication should be 0. For a particular matrix, if I find out eigenvectors, two distinct eigenvectors, then their multiplication should be 0. So the question here is that following statements are made regarding a matrix AM cross N. And the column space is orthogonal to row space, the column space is orthogonal to left null space, the row space is orthogonal to null space, and the null space is orthogonal to left null space. These statements are given to me. Now they are asking me that which of the above statements are true. So if I'll say what is column space, so let's say if I have a matrix and if I row reduced it and the columns which have pivot entry, that would become my column space. And if I'll talk about row space, if I'll row reduce it, the rows which have pivot entry, those rows would become my row space. And if I'll talk about null space is AX is equals to 0. The solution of this equation, all those solutions, that means all those X are form my null space. And if I'll write down A transpose X is equals to 0, then this would give me left null space. So all those value of X which satisfy A transpose X is equals to 0 gives me left null space, right? So that is the difference between null space and left null space. Now, because we are doing Ax is equals to 0, if I'll row reduce it, we know that after row reduction, it does not change the solution. It would become Rx is equals to 0. So that means if I'm multiplying rows of R is what? Row reduced form of A. If I'm multiplying rows of R with X, I'm getting 0. That means if I'm multiplying row space with my null space, I'm getting 0. That means row space and null space are orthogonal to each other. So row space is orthogonal to null space. That is true. And then they are saying A transpose X is equals to 0. A transpose becomes, now the column space will become rows, right? Now because previously I have taken column space as the columns of the matrix A which has pivot entry in row reduction form. Now if I'll take the A transpose, so that would, it would become R transpose X is equals to 0. Now if I'll talk about the rows of this R transpose, that would be my column space. So if I'm multiplying my column space with this X, and this is what? Left null space, I'm getting 0. So that means column space is orthogonal to left null space. That is Q is true. And they are saying column space is orthogonal to row space. That is not true because we do not know anything about that. Null space is orthogonal to left null space. Again, this is also not true. So which of the statement are true? Q and R. So C is correct. Now, next question we have is consider a matrix. So we have given a matrix and they are asking that matrix cannot have rank. This matrix cannot have rank. So we know that if matrix does not have any non-zero entry, then it can have a zero rank. But in this, I can see that we have some non-zero entries, right? I can take any value, I can give any value to A, B, C, D. I cannot have rank 0 possible, right? So that's why option A is incorrect. Option A is incorrect here. Matrix cannot have rank 0. Also, let's say if I'll take 0, 1, 0, A, 2, D, and B, 3, C. So let's say if I'll take any value, I can give AD, BC 0. 0 1 0 and 0 2 0 0 3 0, and you can see that you can make 2 and 3 0 with the help of this one. So matrix can have rank 1 possible. Similarly, matrix can have rank 2 possible as well. If you will take A is equals to 1 and other BCD as 0, then matrix can have 2 value rank 2 possible. And if I'll take A and C non-zero and B and D 0, I can have 3 rank possible as well. But the rank cannot be possible, that is 0. So option A is correct. Now next question we have is consider a schema. We have given a schema R, A, B, C, D, E, F and the functional dependency that A to B and C to D and E to F. The number of super keys for this schema is. So for super keys, we know that we have to find out candidate keys. Now for candidate keys, we will find out closure attributes. So I can see that A goes to B. So that means A plus would be a closure attribute of A plus would be AB, and closure attribute of C plus would be CD, and closure attributes of E plus would be EF. Right? This would be closure attributes, right? So I can see that ACE, if I'll add ACE plus, I'll get ABCDEF, right? And candidate key is basically attribute closure which have all relational attributes, right? So here ACE is my candidate key. And super key, we know that super key is basically candidate key plus other keys, other attributes. So with this, because I get candidate key as ACE, I can take any another attribute. So I can take ACE, let's say B, ACE, and I can take D, and ACE, I can take F. Right? These three value possible. Now I can take two values, ACE, BD, ACE, DF, and ACE, BF and ACE. What another value? I can take BD, DF, BF, and BKS, and then 1, 2, 3, 4, 5, 6, and I can take that BDF together, ACE, BDF. Which one value I left with? BF, DF, BD, ACE, and I also can take AC, right? I also can take AC. So how many super keys possible? So we have total 8 super keys possible, because super key is basically candidate key plus other attributes. So I have considered all those possible super keys. Next question we have is from machine learning. It says that given a data set 1, comma 1, 3, comma 3, 4, comma 4, 5, comma 5, 6, comma 6, 9, comma 9, 0, 3, 3, 0, assuming the initial centroids for K3 minus 3 mean clustering to be C1, C2, and C3. One iteration of the expectation maximize for K means clustering will update to C3 to A, comma A. Then the value of A, comma A is. So, what is K clustering? Basically, K clustering that means that I'll take this C1 as my median and take all the closure points with the C1 cluster, with the first cluster. So I can see that 3, comma 3. If I have taken 1, comma 1 is closure, I have 3 clusters, 5, comma 5 and 6, comma 6. So if I'll consider 1, comma 1 point, it is closure to 3, comma 3. So I'll consider this in one cluster, and 3 comma 3 is itself this point, 4 comma 4, and I now 4 comma 4 can be considered in 3 comma 3 cluster or 5 comma 5 cluster, because it is equal to both the points. So I am taking it in 4 comma 4. Now this 6 comma 6 is closer to 5 comma 5, so I'll take it. Okay, 6 comma 6 is already given me as a third cluster, right? 6 comma 6 is given to me here. 9 comma 9, because 9 comma 9 is closer to this 6 comma 6. This is my point, this is my point. 6 9 comma 9 is closer to 6 comma 6. Now 0330, it is closer to 330330. So these are my three clusters. So one cluster is this is my second cluster, this is my third cluster. So you can take 4 comma 4 in the second cluster as well, but we only need third cluster because we have to update C3. Now what is the formula for updating the cluster? I'll take a average of these values. So third cluster update would become 9 plus 6 by 2 and 9 plus 6 by 2. That means 15 by 2 comma 15 by 2. So a value would become 15 by 2. I can write down this as 7.5. So the third cluster gets value 7.5. We'll update to 7.5 comma 7.5. That's how we basically form clusters in our K clustering. Okay. This is next question again from machine learning. This is neural network basically. Consider a multi-layer perceptron model with one hidden layer and one output layer. Hidden layer has 10 neurons and output layer has 3 neurons. And input we have given is 5-dimensional vector. Each neuron is connected to every neuron in the previous layer and a bias term is included for each neuron. The activation function used in the sigmoid function, we have to find out that how many total trainable parameters we have in our machine learning problem model. MLP model, MLP model, multi-layer perceptron model, right? So that means at the start we have five, 1, 2, 3, 4, 5, 5-dimensional vector. Then we have a hidden layer which has 10 neurons. I'll see that 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we have an output layer which has 3 neurons, right? So I know that what would and they are saying that each neuron is connected to every neuron in the previous layer and a bias term is included. So that means this neuron is connected with all the 5 values. So what would, let's say if I'll consider this as x1, x2, x3, x4, x5, so what would it would become at this point? What would it would become? W1 x1, w2 x2, plus w3 x3, plus w4 x4, and w5 x5, and then we'll add one bias term, right? So that means at this neuron we have 6 trainable parameters. Similarly at this point as well we have 5 wi's and then one bias term, that is 6 parameter, and at this position as well. So that means at this hidden layer how many trainable parameters we have? 60 trainable parameters, 6 into 10. Similarly at this point, because this value this is connected to all the 10 neurons, so we have 10 wi's and one bias term. So we have 11 parameters here, 11 parameters here, and 11 parameters here. So in total, we have 33 parameters. So if I'll add all those parameters, so how many trainable parameters I have? 60 plus 33, that would give me 93 trainable parameters. So total number of trainable parameters are 93 in this case. Okay, so that's how we'll find out number of trainable parameters. Okay. So either you can do this thing as well, you can apply the formula. Let's say if I have number of neurons in a layer is n, and we are connected with, let's say, w vectors, w dimensional vector, then I can write down n into w plus 1 if I have to find out number of trainable parameters at this position. So 5 plus 1, that is 6, into 10, that is 60. And at this level we have to apply 10 plus 1, that is 11, and then we have n, that is 33 parameters, right? So that's why we get 93 trainable parameters. Next question we have is companies manufacturing product at a rate of p units per day, right? And the cost per unit is C is equals to 230 plus 0.1 P plus 9,000 by P. Selling price is rupee 300, production level minimizing the cost per unit and total profit per day respectively are. So we have to find out that, because companies manufacturing P units per day and we have to minimize the cost. So that means I know that to find out minima and minima, I'll find out a differentiation and I'll equate it with 0. So dc by dp would give me differentiation 0.1 and minus 9000 over p square, right? So if I'll solve this, I'll get p square is equals, if I'll equate it with 0, right? So that would give me 90,000, because point 0.1 gets in multiplication. If I'll solve this, I'll get p is equals to 300. And if I'll find out d square by d square c by dp square, that would give me positive value. So we'll have a minima at p is equals to 300. So we are getting minima at p is equals to 300. If we are getting minima at p is equals to 300, they are asking me to production level, that minimizing the cost per unit. So production level, that is, so we have to produce 300 products, and what would be the minimum cost per unit? So cost would be 230 plus 0.1 p plus 9,000 divided by p. This is my cost. So if that means I have to produce 300 products to get a minimum cost, right? So that, let's find out the minimum cost. 230 plus 0.1 into 300 plus 9,000 upon 300. That would give me 230 plus 30 plus uh that would give me 330, that is give me 30. So that would become 290. So that means we have to, the cost per unit would be 290. The cost, minimum cost per unit would be 290 if I'll produce 300 articles, right? So production level minimizing the cost per unit would be 290. Now we have to find out total profit. Profit would be selling price minus cost price. Selling price is giving me 300. So to find out a profit, I have to take selling price minus cost price, 300 minus 290, and total number of articles I am making. That means I am manufacturing 300 products. So that would give me 3000 profit. So I can see that 290 comma 3000 is correct in option A. So here option A is my correct option. Okay. Now, next question we have is probability. It says that a class contains 60% of students who are incapable of changing their opinions about anything, and 40% of students are changing their minds at random, with probability zero point 0.3 between subsequent votes on the same issue. So getting a same vote on a same issue would be 0.3. Then we have to find out probability of a student randomly chosen voted twice in a same way. So for that we have to use law of total probability. So I'll show you how we have to use law of total probability. So I'll consider A as students who are incapable of changing their opinions. Students incapable of changing their opinions. Incapable of, that means they are not changing their opinions. I'll consider in A, changing their opinions. And B would be students, they are students changing their mind at random. Students changing mind at random, right? And let's say C would be that student vote twice in same way, right? So I can see that there are 60% of students that are incapable of changing their minds. That means probability of A would be 0.6, and probability of B would be 0.4, because students who are changing their mind. We have to find out probability of C. Now by law of total probability, we know that I can find out probability C would be probability of A into probability C given A plus probability of B into probability C given B. And I can find out probability C given A. What would be probability C given A? Students voted twice in same way if they are not, if they are incapable of changing their minds. If they are not changing their minds, then the students voted in twice in same way would be 1. This probability would be 1. And probability C given B, they have already given this, that with probability zero point 0.3 between subsequent vote on the same issue, right? So zero point 0.3 is the probability that they would give same, uh, they would choose, they would vote twice in the same way, right? Or they would, on same issue they would vote twice. So I can now find out the probability. 0.6 into 1 plus 1 plus zero point 0.4 into 0.3. That would give me the probability. That means 0.6 plus 0.12. That would become 0.72. So 0.72 is a probability that a randomly chosen student voted twice in a same. Now, next question is again from probability. It says that O1, O2, O3, O4, O4 represent the possible outcomes of a random experiment. Probability of O1, O2, O3, O4 are equal. So I can say that probability of OI would be 1 by 4, because each have the equal probability and we have four options possible. Consider the event P, Q, R, and S. Then we have to tell them that which of the statements are true. P and Q are independent, P and Q are not independent, R and S are independent, or Q and S are not independent. So we have to tell them. So we know that for an independent event, let's say if I have to find out P and Q are independent, so that means I have to find out that probability P intersection Q would be equal to probability of P into probability of Q. So probability of P intersection Q, if I'll check. So O1, O2 and O2, O3, their intersection is O2 and probability of O2 would be 1 by 4. Probability of P is, we have two elements, so probability would be 2 by 4 into 2 by 4. So we'll get this as correct because left hand side is 1 by 4, and if I'll solve this, I'll get this as 1 by 4 as well. So that means P and Q are independent. So A is true, B is not true. Let's talk about C. R and S are independent. R is what? O3, O4, and S is O1, O2, O3. So let's find out probability of R intersection S is equals to probability of R into probability of S. R intersection S would be O3, O4, O1, O2, O3. Their intersection is only O3. So probability would be 1 by 4. R would be 3 by 4, 2 by 4 probability, and S would be 3 by 4 probability. I can see that they are not equal, so that's why they are not independent. And next is Q and S are not independent. Again, let's check for Q and S in the similar way. Probability Q intersection S and probability of Q into probability of S. Q intersection S would be O2, O3, O3, sorry, O2, O3 and O1, O2, O3. So their intersection, we have two common values. So 2 by 4 would be the probability Q intersection S. And probability of Q would be 2 by 4 and S would be 3 by 4. Again, they are not equal. Q and S are not independent. And if they are not independent, so D is true. So in this question, A and D statements are true. Right? A and D statements are true. Now, next question, it is from linear algebra. The question says that consider the matrix X whose eigenvalues are 1, -1 and 3. Right? So we have given 3 eigenvalues. We have to find out trace of x cube minus 3x square. Eigenvalues of x is given 1, -1 and 3. What would be the eigenvalues of x cube minus 3x square? I can find out that if I'll find out all the eigenvalues, then sum of eigenvalues is trace. That we know. Now, eigenvalues of x cube minus 3x square. That would be 1 cube minus 3 into 1 square. Right? And then next eigenvalue would be -1 cube minus 3 into -1 square. And the next eigenvalue is 3 cube minus 3 into 3 square. So if I'll solve this, 1 minus 3, that would give me -2. And -1 minus 3, that would give me -4. And that would give me 327, that would give me 0. So I have eigenvalue -2, -4 and 0 for this matrix x cube minus 3x square. Right, this is one of the property of eigenvalues. Right, if lambda is an eigenvalue of A, then lambda square be an eigenvalue of A square. Lambda cube would be an eigenvalue of A cube. And if I'll write down A cube plus A square eigenvalue, that would become lambda square. Right, so this is a property eigenvalues have. So I have used that to find out a trace. So trace would be -2 plus -4 plus 0. That would give me -6 as a trace or this matrix x cube minus 3x square. So we have this question. In this question, we have to find out output of the Python program. And we can see that this Python program we have given is I is equals to 1, j is equals to 1. And for I in range 1, 11, we have to check that if I percentage 3 is not equals to 0. That means if I'll divide 3 if I'll divide I with 3 and we are not getting a remainder 0, then j would become j plus 2, right? And then we'll continue. If j percentage 3 is equals to 0, that means if I'll divide j with 3 and we get a remainder 0, then we'll break and we'll print I plus j, right? So this is my Python program. So what would I do? I'll try this loop. So let's say I'll start with I is equals to 1. When I is equals to 1, I can see that if I divide I with 3, I'll not get a remainder 0. So j would become j plus 2, and we have initially j is equals to 1, so j would become 3. Now for I is equals to 2, j would become 5. And for I is equals to 3, when I would become 3, this would become 0. So j value does not gets added, right? And if and this is also not true if j percentage 3 equals to 0, because if I'll divide j with 3, I'll not get a 0 value. So I'll again run this loop for I is equals to 4. For I is equals to 4, 4 percentage 3 is not equals to 0 again, so j 2 value gets added here. So j is equals to 2. Now for 2 value get added here, so 5 plus 2, that would become 7. Now when I would become equals to 5, again this loop would run. When I will be 5, remainder is not 0. After dividing it by 3, then 2 value gets added in j, so j would become 9. Now when I would become 6, this would give me 0, right? This would give me 0, so this loop does not run. Now for this one, for j percentage 3, this would give me again 0, right? Because j is 9 now, and if I'll divide it by 3, I'll get a 0 value, so our function would break and we'll get I value. Finally we get 6 and j value we get 9, so that means 6 plus 9 gives me 15. So print I plus j, I plus j would give me 15 value, so D is correct, right? So that's why I have to run the loop and see what the value I'll get at the end. So yeah, this is the next question. It says that assume that S is a stack and Q1 and Q2 are two queues which support the NQ and DQ operation. Consider the following pseudocode for implementing the pop and push operation on S. So we have given a function which are defining push and pop operation. Which of the following options for the function A, B, C, D correspond to correctly implementing the push and pop operation on the stack S? So first of all, what is a stack? So in stack, if talk about a stack, let's say if I'll insert one number. So let's say if I'm inserting 1, so it goes at the end. And if I'll inserting another number, that would become 2. And if I'll add one another number, that is 3, that is, and next number is 4. So that is a push operation. That means I am pushing operation. I am pushing numbers in this stack. And if I have to pop, now if I'll pop, my 4 value gets, I'll get 4 value. So if I'll pop out of this stack, then I'll get a 4 value. If I'll take the 4 value outside and then if I'll again apply pop, then I'll get a 3 value, right? That is push and pop in a stack. Now they are asking that I have to using two queues, I have to apply this using this push and pop operation. I have to create a, in stack we can see that we have last in and first out, right? So last in first out work on stack. And if I'll talk about a queue, so if this is a queue, let's say if I have inserted a number, that means 1 2 3 4, I have inserted these numbers in a queue, then which goes to the first, that comes out. So that means first in first out in a queue. Now I have to check that using this push and pop operation in two queues, how can I define a stack? How can I perform operations of push and pop on stack? So if I'll see what we are having, we are having two queues, Q1 and Q2. So let's say we have two queues, Q1, this is Q1 queue and this is Q2 queue. So now first of all, they are saying that I am inserting a Q2 comma X. That means I am inserting, I am enqueuing one value in Q2 with X. So that means A is what? A is inserting, because there is nothing in Q2 right now, so we cannot DQ. So A would be NQ, right? So I have to define either N, A, B, C, D, or NQ or DQ. So A is NQ, that is clear. Now they are saying that while Q1 not empty, if Q1 is not empty, then we have to run this. But right now Q1 is empty, so we will not run this. We'll swap Q1 and Q2. So if I'll swap Q1 and Q2, let's say if I have taken one value here, so now it would become, this would become my Q1 and this would become my Q2, right? And then they are saying pop of s, return dq1. Return dq1, that means I am taking one value out of this q1. So that means d would be, I can understand that would be dq, because that is a pop operation. I have to take one element outside. But now I have to define here what would be b and c value. Right now q1 not empty. So right now q1 is not empty. What would I do? I'll take c of q1. Right. So what they are doing, they are taking one out. If I'll take one element, this one element out of this q1, let's take this one element outside. Then if I'll insert this element in this q2, q2 row, and if I'll swap q1 and q2, what is happening here? That means I am running this push operation again. Let's say if I am adding two element in this q2, right? What I have done, I have added two in this q. Let's say first of all, I have added one element correctly. I have added one to q2, and then I have interchanged. I got one in q2, q1, and there is no element in this q2, right? So this is one step. Now for the second step, what would I do? I would add another element in q2. Let's say I have added this element 2. Now, while q1 not empty, q1 is not empty here. So what would I do? I'll take a element out of this q1, right? I'm taking this 1 and I'm adding this in q2. So that means q2 would become 2 and 1. This would become q2 and q1 would become empty, right? So if I'll interchange q1 and q2, what would I get? I'll get this 2 and 1. That means in q2 now I have 2 and 1. 2 and 1. Now if I'll pop one element out of this q2, what would I get? 2. I get 2, right? But you can see that in q2 I have inserted first element as 1, right? And it is what, on what concept it's working? Last in first out. So that means we one is going uh inside this queue and we are getting two out. So that means the element which is going at the last and it is coming outside, like that is we are defining a pop function here. So that's why we can see that this b would be, that means b would be nq, B would be NQ, and C would be DQ. Right. So I can see that option A would be correct because A and B are NQ and C and D are DQ. Okay, so option A is correct. Now next question again we have is of Python program. It says that import math, because we are using some functions of math, and then we have defined function ABD. N1 and N2 are 0 and we have given the flag value 1. For I in range D, I'll take N1 is equals to N1 plus I square, N2 is equals to N2 plus BI square. For I in range D, AI is equals to AI upon maths square root of N1, BI is equals to BI upon square root of N2. For I in range D, AI not equals to BI, flag 0, right? It would break. So that means we'll get flag 0 when AI is not equals to BI. Right. So they are asking that for which of the following input does the above algorithm produce 1 as an output. Right. So we want that flag value doesn't get changed, and flag value is getting changed when AI is not equals to BI. So I can say that flag value is getting changed when AI is not equals to BI. So I want to consider all those cases where AI is equals to BI. And what is AI? AI is basically AI upon square root of N1, right? And N1 is what? N1 plus AI square. So that means I can say that AI is what? AI, or I can say that A1 upon AI. Let's write down this as AI, A1, uh, A1 square plus A2 square plus A3 square plus A4 square, square root of this, and equals to BI equals to B1 square plus B2 square plus B3 square plus B4 square. So that means I want all those numbers where A1 equal A1 upon square root of A1 square plus A2 square plus A3 square plus A4 square equals to B1 upon B2 square, B1 square plus B2 square plus B3 square plus B4 square root. So I want all those arrays, right? So if I'll see here, when would I get these two values equal? That AI upon square root of this value, BI upon square root of these values are equal, right? When would it happen? When they are multiple of each other, right? So you can see that if I'll take this as 1 and this is 2, if I'll take a square root of this and square root of this, so I'll get the same value because you can see that they are multiple of each other. 1 into 2, 2 into 2, 3 into 2 and 4 into 2. So Q is correct. Similarly, R is correct because in Q and R they are multiple, in P and S they are not multiple. So that would not be correct, right? So you have to, because we cannot run this function by ourselves, or we cannot start with I is equals to 1, I is equals to 2. So that's why we have to take this, we have to understand using this maths. Okay, so yeah. Next question we have is, consider the following undirected graph on 5 nodes. Assume that you are performing breadth first search on this graph using a Q data structure. How many unique breadth first orderings are possible? We have to tell them. Right now, for breadth first ordering, we can start from any vertex. Right. So let's say if I'll name these vertex 1, 2, 3, and 4 and 5. Right. I have 5 vertices here. So there might be a possibility that if I'll start with first vertex, because they do not have given me any of the vertex, if they will give me first vertex, then I can move to adjacent vertex, that is 3. Now for after this 3 vertex, there are 3 adjacent vertices. So how many possibilities are there? We have 3 factorial possibilities. Similarly, if I'll start with 2, then I can move to 3, and then again I have 3 factorial possibilities. Similarly, if I'll start with 5, I have 3 next would adjacent vertices, and then I have 3 vertices possible, 1, 2, and 4. That would be 3 factorial. Similarly, for 4, we have 3 factorial possibilities. And at the end, if I'll start with 3, I can move to any of the vertex instead. Either it can be 1, 2, 4, and 5. So how many possibilities I have? 4 factorial. So if I'll add all these possibilities, what would I get? 4 factorial plus 3 factorial plus 3 factorial plus 3 factorial plus 3 factorial. What would it give me? You can solve it. You will get C as your answer. That means 48. In total, you have 48 orderings possible for this breadth for search in this. Yeah. So this is another question. It says that value of a real variable x greater than equal to 0, which maximize the function. Again, this is from calculus. To maximize any function, what would I do? I'll take a first derivative f dash x. That would be x to the power e as it is, because this is a product of two functions. So I'll differentiate using product rule. So that is a differentiation. Let's write down the differentiation. Right. So this is a differentiation. I'll equate it with 0. And if I'll take common, I'll left with 1 minus x, or minus x plus 1. I can take common x to the power e minus 1, e to the power minus x. So this value cannot be 0. This value cannot be 0. So minus x plus 1 can be 0. So that would give me x is equals to 1. So that means x is equals to 1 maximizes our function. And you can find out the double derivative. You will see that double derivative sign would be less than 0. That would tell you that x at x is equals to 1, we'll get a maximum, right? So I can find out this f of 1, what it would be. 1 to the power e, e to the power minus 1. So 1 to the power e would be 1. And in this e to the power minus 1 would be 1 by e. Right now you can solve it using calculator. This would be your maximum value. 1 by e gives you your maximum value, right? And this is my last question from DBMS. It says that consider the following relation schema. It says that employee ID, employee name, and employee department, and customer ID, customer name, uh, sales rep ID is a foreign key referring to employee ID. Okay, and then we have a rating. Now they are given us a query. They have given us a query. In this, they are saying select employee name from employee where not exists. Select customer ID from customer C where C dot sales rep ID is equals to E dot employee ID, and C rating is not equals to good. So that means, let's see this inner query. In this, we have to select all those customer ID from the customer table where customer sales ID is not equals to employee ID, and their rating, customer rating, is not good, right? So I'm finding out this in this inner query, and I have to take all those values which are not included in this query, right? So because they have written here where not exist, so we want to find out all those employee with which our customer ID have a good rating, and their customer sales ID is equals to employee ID. So we want customers, we want employees which have those customers which have a good rating. right? So I can see that if you will go through the option D would be the correct, because name of all the employees with all their customers having a good rating. Because in this we have, in this inner query we have found out that all those customers which do not have a good rating, right? And here I have found out that I do not have to take which do not have a good rating, so I have to take all those employers which have a with whose customers have a good rating. So in option A and B, they have used at least, at most, it is not required, and none of their customers having a good rating. But we have that in inner query and we have used not exist. So that's why option D is correct. Okay, so these are most of the questions for GATE data science sample paper. And I told you that I'm going to analyze that paper as well. So you can see on my screen that we have solved here. We have questions here: 11 machine learning, 12 probability statistics, 8 calculus question, 5 linear algebra, and 7 data structures and algorithm, 4 artificial intelligence, and 8 DBMS question. So you can see that all the subjects have uh, have kind of equal weightage if I'll not consider linear algebra and artificial intelligence. And if I'll talk about most important subjects for data science, that is machine learning and probability and statistics. And also from solving all those questions we get an idea that what kind of question paper we can expect. There are two difficult question as well as easy questions which are given in calculus, and also we have easy questions in machine learning where they have asked about simple number of parameters required. So we have all those types of questions included. So if you will go through all the concepts, then you can easily solve it if you have all your basics clear. Okay, so all the best for your preparation. I hope this session would be helpful for all of you. Thank you.